And yeah, I call it Temporal, but yeah, I'm sure there are people within the company, they call it different names. Yeah, we reached out on our community site, and I was happy to be here and give you guys an introduction. I just go ahead and start my slides because I have one slide about kind of like about me thing. So if that's okay, I'll go ahead and share my screen now. Is that okay?
That's great.
All right, let's go. Let's try it this time. All right. So anyways, let's start up. All right, can you guys see everything fine?
Yep.
All right, let's go. So anyway, so thank you again for having me present. In this talk, I'm going to talk about Temporal, and kind of like Temporal is an open source and reliable, scalable microservice orchestration. And hopefully, after this talk, you guys, I will be able to explain really what it is, how you use it, without just throwing some buzzwords at you. So my name is Tihomir. I know it's hard to pronounce, especially for Paul, it seems, but I am a developer advocate at Temporal. I've been there around 6-7 months now. I'm also project lead at the CNCF Workflow Specification. And before Temporal, I worked for many years at Red Hat. I was a developer on their business automation team. And I'm a big workflow tech enthusiast, and that's just my handle for Twitter, I guess. Anyway, so I wanted to just show some links for Temporal so you guys are kind of familiar. There's a website, docs, the community website. This is kind of like where if you have any questions, you can go to community Temporal.io and ask anything. Of course, GitHub, Temporal is open source, MIT license, and you can see all the sources there and also contribute if you'd like. We also have meetups just like you guys, and you can go to this URL to check. I think there is one next week. So if you want to meet the team, meet the developers, meet everybody around Temporal, you're more than welcome to join and get in there. And also at the bottom, I just have an email. If you have any questions, they're like not about open source and stuff like that, but more about the product side, or any questions so you don't want the community to expose, you can use this email address to ask any questions. Temporal right now, I think it's an understatement to say it's kind of pretty hot in the open source space right now. And we also have a bunch of case studies. If you go to the website, you'll see all the links there, and you can actually read and not get it just from me that works at Temporal, but you can also read about a bunch of different case studies about companies they're currently using it on their production system. So I think this is really cool. This is kind of like their kind of write-ups of what they're doing, how they're using Temporal, and what the use cases are for them, where they chose actually to use it in their production systems. So anyway, so to kind of start talking about Temporal, we have two things to talk about. Number one is the Temporal Server, and then the other thing is the Temporal SDKs. And if you look at Temporal Server, it's just really a Golang binary. There is nothing more to it. And you can deploy this binary on Kubernetes. I've deployed it locally on Minikube, on K3s, whatever. For local development, most of the users of Temporal, and especially people new coming in, deploy it on Docker using Docker Compose. But really, you can deploy it in any infrastructure that you have available. Now, yeah, this is not a plug, but Temporal does provide Temporal Cloud, and which kind of offloads that deployment, and a lot of people are using that as well. As far as the SDKs goes, those are the SDKs provide different APIs that we will take a look at throughout this presentation. And we currently have in Go, PHP, Java, Node. You can use these SDKs in any type of frameworks that you use, depending on your programming language, and you can also run it, of course, with that on any type of infrastructure or your deployment model that you currently have available. So we said the server is just a Golang binary, but let's kind of take a look at what's inside. The Temporal Server is really a grouping of 5 services. We have things like Frontend Service, History Service, Matching, and we'll go through each one of what it does. And then we also have the database, which allows you to stores a bunch of different information, allows your actually applications to be persistent and stateful. As far as server scalability goes, you can scale temporal. You can scale it out by deploying more of sets of this library and its services on multiple clusters. But you can also scale up each individual part or service of the temporal server can be scaled individually, and you can scale them depending on your loads, your needs, and whatever type of application requirements you might have, and how much use or how many customers are hitting that thing in the end. So let's take a look at just each one of the services in the temporal server. So it has a front-end service which exposes a gRPC API. This is kind of like the front-end service where everything goes through. So this is kind of your application. So we will take a look at how I actually communicate with the temporal server and things like that. So it handles all inbound calls. It allows for multi-cluster replication, and of course, you can communicate with other services of the temporal server. The history service manages some workflow state transitions. This is instruction on how your mission-critical code and application actually transitions from one step that you define to the next step that you define. The matching service hosts these things called task queues, and we'll take a look how that goes. Those are dynamic task queues that get generated, again, depending on your application and what it does and how you actually define things to be done. The worker service is there's a lot of background processing going on, such as replication queue, system workflows. Those are particular workflows that run within the temporal server and manage parts of it as well. As far as the database goes, or the persistence part of the temporal server, Temporal currently supports Cassandra, MySQL, and PostgreSQL. And within the database, it stores a bunch of different things like workflow tasks or the information of the instructions of your particular code or application that it has to execute. The actual workflow data, such as the inputs that you provide to your application when you started. Go ahead. Oh, I thought somebody had a question. Anyways, I'll continue. So we also, the database also stores workflow events, which are every single event that happens during the execution of our application, and also things like visibility. So in addition to actually your application, you can give special instructions about some sort of visibility information or extra information that you might want to query later on that it's important to your business as well. Now, the scaling of the database really, of course, depends on the database that you use. For example, with Cassandra, it's probably much different than MySQL and so on. So that's kind of like something that you have to look into when you think about scaling the database in this case. So observability, I'm a big fan of that. Of course, you want to be able to see everything that's going on in your application. You want to be able to monitor it and things like that. So both the temporal server and the temporal SDKs produce metrics, and there's tons of metrics, and I can also provide links to actually see everything that's going on. And anyway, so those metrics can be out of the box, consumed by things like Prometheus. And also we have a bunch of different dashboards that you can build. Of course, from the server side, those dashboards will be more targeting your sysadmins and people that are monitoring and scaling and working on the temporal server side. And also the SDK metrics give also a lot of information about it's more kind of can help you improve your development process and stuff like that. In addition to that, this is not something that you have to add on or something that comes when you use the open source solutions. The SDKs also provide tracing information that you can then use, in your favorite open tracing or whatever, in this case, Jaeger, and display as well. So yeah, I kind of, talked about the server, the details, but, I like to look at things from the point of view of some sort of persona or whatever. But so let's kind of put our, developer hat on and see, how do I see the temporal server as a developer? Well, I don't see in there what's inside, what kind of services are in there, what's a front-end service, matching service. No. What I see as a developer within the Temporal Server is basically a server, a thing that allows me to deal with events, things like timers, databases, transaction management. So the Temporal Server is fully transactional in everything that it does, and reads and writes and stuff like that. I see something where I don't have to myself deal with queuing, and I get analytics and metrics out of the box. So when I write my application, or I write my code, or I get my requirements as a developer to actually build something that my company wants me to do, I don't have to deal with any of this stuff. And that's kind of like, as a developer, a big benefit I see, from startup, from Temporal. Now, as far as the server goes, Temporal is not a joke. A lot of times, you actually probably seen workflow runtimes, and they've been around for 15 years. They focus a lot on things like, UI, flowcharts, the way you define your workflows. Well, Temporal, as you see, does both. And your Temporal Server is capable actually to execute hundreds of millions of these things called workflows that we'll look in a second concurrently. So it is a highly scalable production level system. And if you go back in the slides and see actually the use cases or the companies, you will see that some of them are really using it at a very high scale. Temporal Server does not execute your code directly, and that's actually kind of cool, and we'll take a look at that in the future slides as well. But rather, it tracks and manages your application as far as it has to be executed, and also tracks and manages the state of your application as well. So any questions so far? Sorry if I'm going too fast or anything. No? All right, let's move on. So let's kind of look at the SDKs. We've shown the 4 that are currently available. And what do the SDKs provide? They basically provide you some set of APIs on top of of course, the programming language that you choose. And those APIs help you with development, testing, and also there is a client API, which means a client API that you can communicate to the Temporal Server. Now, of course, you can write, since the Temporal Server, as we saw, the front-end service exposes is really a gRPC client, you could actually use straight gRPC if you wanted to, but the APIs provide you a nice client API to do that. So anyways, as a developer, what am I working with? Still, I am using my favorite IDE of choice. It doesn't have to be IntelliJ, of course. And I have to really focus on developing 3 things. The first thing is workflows. And workflows are really deterministic implementation of your business logic. Again, giving the Temporal Server, we have to focus on the business logic and all things like transaction management, database, storage, and things like that, and all these other things. And workflows orchestrate activities. And we'll take a look at activities, but basically what that means is in your workflow, you have your base business logic that has to be deterministic, and we'll go through that as well. And it can orchestrate or make calls to something called activities, which can translate into invocation of different third-party services or access to a database, file system, whatever. So the important thing about workflows is this fault-tolerant control flow logic. So it allows you with the Temporal Server and writing workflows to have things like configuration-based automatic retries. You can have timeouts just without really thinking about how to implement timeout. You can start workflows as for example, a cron and a continuous execution based on some time definition. Temporal also API support compensation, or the saga pattern. I just call it compensation, really. You have things like sync, async execution, signals, or how do you actually communicate or send events to your application, and a lot of different things. But on top of that, since these workflows are the way you represent your business logic, uses a programming language in Temporal, you have all the features of the programming language that you use. So, let's go to the next step. So the next thing is activities. Activities really represent your own code. So like we said, invoking a service, a file access, accessing your database where you have to get some storage from. That can be non-deterministic. It can really execute any code you want. And again, activities can be invoked sync, async, And of course, activities or can be rate limited through configuration. For example, you don't want to flood third-party service that you're invoking and things like that. And also everything is through some sort of configuration-based approach. The third thing, of course, it's important are workers. Workers are processes that host workflows and activities. So the way this works is you actually register your workflows and your activities with one or multiple workers, depending on your scale. So you also have the scalability part on your API side, on your application side. And the workers are responsible to communicate with the temporal server for you. And we'll kind of see through some sort of animation how that works. And the workers are responsible to, for example, start the execution of your code based on some signal or some sort of event that happens, and also communicate with the temporal server when to continue executing, when the execution should stop, and things like that. And remember, with temporal, you can have workflows that run for years. So the workers are also responsible, for example, stopping workflow execution and putting it in a halt until a timer on the server side says continue, and you will not utilize any of the resources on your actual application and where you define. One of the important things that a lot of companies are worried about is, okay, if the temporal server actually controls everything about my application, how the control flow logic should work, what about my data? I don't want to store, or the database on my temporal server side, to store any of my private information. And you can also, through workers, configure privacy setting through which you can encrypt, for example, your data going in and coming back from the server, so you have nothing to worry about on that end as well. Now, as on development side, Temporal does provide a web UI where you can kind of see what's happening, what workflows are running, and what events are associated with each of the invocations of your applications, and things like that. But it also provides a CLI called TCTL, and you can go to the docs. You can easily install, which includes all of these functions of the web UI and much, much more, things like batch execution, batch deletion, resets, a whole bunch of stuff and that you can do with the CLI that currently are on top of the functionalities of the web UI. So as far as me being still a developer and I want to do testing, again, I'm still in my IDE. I don't, and I say this because in a lot of times when you adopt a workflow solution, you have to change the way you think, you have to change the way you develop, you have to use the tools and a lot of different things provided by that particular workflow runtime. In this case, I'm still in IDE, I'm still writing my code in the programming language that I choose, and I can still debug my applications regardless of what's going on or if you're using Temporal or not. So when I'm testing my workflows, Temporal, through its API, includes a testing environment or testing API where you can test and mock your workflows using different frameworks. For long-running workflows, again, this SDK provides time advancing. So if you have a workflow that you're testing that should run for 10 years, you can really test it within milliseconds. You can still use your mocking framework of choice, given your programming language. And even for testing through the API, you don't really have to have the temporal server running. So if you're testing it locally and you want to just test, you don't have to be connected even to the internet in this case. Activities can also be tested and debugged. They can be also tested independent from the workload. So you can have some sort of unit versus integration testing type of approach as well. The next thing I wanted to talk about is, okay, now we've seen this from the developer perspective, but what about if I'm like some sort of architect, or I don't know the position, how developers really do everything these days, but just to kind of give us some sort of distinction. If I'm an architect or I want to design either a new or I have an existing application where I want to introduce Temporal, the first thing I'm going to think about, hey, can I use the frameworks that I really want to use for whatever applications I want to write? And with Temporal, yeah, because you have a programming model, you have an API that's based on a programming language, you can still use any framework that you're currently building or think about building new applications with. As far as programming language, we went through this already. Yes, I can use this. What about my dev environment? And we also showed, yes, I can still use my IDEs. I can still deploy either on development or testing or production, whatever the stage of your deployment is. I can still deploy it on Kubernetes. I can deploy my code still, whatever infrastructure you might be using. And what about testing? Can I still use JUnit? Can I still use Testify? Yes, and that we've shown that as well. Now let's take a look. One thing that is interesting to me is, okay, writing new applications is cool, but what if I have an existing application that I want to actually start using Temporal with? How can I do that? And in terms of existing applications, this is kind of like a common. It's not every application like this, but you have some sort of data model that represents your business logic. You have some event platforms that you use to receive the events or some sort of information either from humans or other systems. Then you have in the middle kind of like your object model, which defines your core business logic or your knowledge of your systems and what your company provides to the end customer. And then, of course, that communicates with different services, UIs, or whatever you have it. Well, from the architect perspective, what you have to think about when you start introducing Temporal to existing applications is which parts of my existing object model do I turn into workflows, which means deterministic executions of my business logic that use the Temporal Server, as we'll see, and which parts of my existing object model do I turn into activities, which are parts of my code that communicate, as we said, with outside systems and do different things. So now, of course, Temporal is not magic. I don't work at Hogwarts, but so let's take a look at how this actually works. Let's say on the left-hand side, and I'm sorry, I've been a Java developer a long time. I'm learning. I learned Go. I really like PHP, but most of when I do demos, my code is in Java, and sorry for that. So let's say you have a business class, let's call it my customer class. And this is the code that you currently have in your application. This is just basic business logic that takes in some sort of customer object or your domain-specific data and updates some account message. You also have a method on the bottom left that retrieves some sort of customer information. And you also have a method called exit, which can be triggered, for example, by an event coming from your eventing system where you actually want to stop your application. Well, on the right-hand side, of course, here we're talking Java and Go. You guys probably look at this and laugh, but we have to define some sort of interface. This interface, of course, is the blueprint of our business class. So the only thing, when we want to turn this into, let's say, a workflow, all we have to do is update the workflow interface. So you'll see with Temporal API, you use some sort of annotation that it provides. So what this change is, I have annotated my interface with @workflow interface, saying, okay, this is a workflow, and whatever class is implemented, they should be treated as workflows. I've updated my update account message as a workflow method, meaning that when my workflow executions should start, this is the entry method or the method that should be called to start execution of this particular workflow. The get customer or the retrieving of the information to outside systems, I've queried with query method, annotated with query method, and the exit method, which should probably trigger by some sort of outside event, and it can also have parameters. In this case, exit doesn't, but you can signal or an event can have a payload that you can also add here as well, and annotated with signal method. And with that alone, my code that I had on my left-hand side has turned into a temporal workflow. Now, what did this bring me? Because of course, I have to use the temporal server. This part of code that I've written without thinking about, storage, transactions, a lot of different things, now has all of a sudden turned into, I can execute this workflow. It can be run for seconds or for years. It became stateful without me having to think about a database storage. It became fault tolerant, meaning that in case of some errors and things like that, faults, this thing can recover from it. I can execute my code periodically if I wanted to without changing any code, just adding a little bit of configuration. I can invoke my code synchronously or asynchronously. I can version changes. It always happen, especially in long-running workflows, and things like that. So, all these things I've added without really a lot of effort. Now, the important thing now that we have defined our workflows, we have to look at how do we interact with this thing? How do we start it, stop it? How do we signal? How do we send an event to this thing? Or how do we get data out of it? But also important thing is, okay, what actually do we have to, are there any rules we have to follow when we actually write the business logic of our workflow? So let's take a look at first, the interaction with it. So when we start writing, of course, we have our client application that uses the Temporal API, or you can do the same thing with the CLI, and we have some sort of Temporal Server running somewhere. The client API sends some commands to the server. These commands can be either start workflow execution, but there is many different more types of commands that you can send to the Temporal server. But let's kind of like stop, go back to, let's say we write a piece of code, which we use the API to start a new execution of a particular workflow. So we send a start command to the server. And of course, now we also have our application. The server, as we said, does not run your application code, but you have your application code, which can have some workflows, activities, and of course the worker. When the start command comes into the server can choose, depending, right now, or based on some timeouts, it can do it in 10 seconds or a year, put a task on a particular task queue, and this is the matching service that we talked about, or part of the server, and just put a task in there saying, hey, we need to start this particular workflow. Your application code or your worker, which uses long poll to this particular task queue, is going to consume this particular task, and this task is going to tell the worker what to do. Do I start a workflow instance? Do I continue it? Do I add event information to it? And blah, blah, blah. So now your application code, once you start workflow execution, it can say, okay, server, we need to schedule invocation of our activity, given some information like, okay, what are the timeouts for the activity? How many retries should we perform? And in which way, depending, if we get some errors and things like that. In that case, the Temporal Server puts again a task on the task queue with that information of what needs to be done next. The worker can pick that up. It doesn't have to be the same worker, and this is why Temporal is a fully distributed system. In this case, it's the same one, but you can imagine it could be a completely different worker if you have a number of workers, depending on the scaling of your application, pick that up and continue execution of the workflow, meaning invocation of this particular activity that we wanted to do. Anyway, so one more thing that's important, and is this on the right side, we see kind of like, okay, this event came, task queue, Temporal Server added an event to the task queue, the worker picked it up, and now what happens? On the left-hand side, we have a piece of code that, let's say it's our workflow, which is a simple method that executes 3 activities. So you can relate to that as, for example, having a pipeline execution that executes 3, some sort of functions out in the cloud or whatever. So what does this workflow task, what does this information contain? It contains the information what to do next, whether, for example, hey, we have failed, or you should retry an activity, or you should sleep for about 10 days or something like that. In this case, it could be execute this. We have completed execution of activity A, go to the next step, and also includes a bunch of past events of what happened so far. And on the left-hand side, if we go top down this line, let's say that our current code is on this particular line, update customer account, where the red dot is. So before actually continuing workflow execution, there is going to be a check or a replay check done. And we're going to make sure that every event that is in the workflow task actually still matches the execution of your workflow so far. That includes the data input to your workflow method. That includes the results of any execution of your activities so far. Now, this happens super fast, but if those things don't match up, your workflow is non-deterministic, and there is some change introduced that shouldn't be there from the last time the workflow execution when it was stopped, and there is going to be some sort of error that happens. So if everything matches up, we're deterministic. Then we look at the what's next command and go down, If it's non-deterministic, well, most likely your execution should stop anyways. Let's take a look at just workflow determinism rules. Now, this does come at a price. Having deterministic execution of your application comes at a price, meaning that you have to use the workflow APIs for different things. For example, side effects, or how do I actually have non-deterministic? What if I just want to have a random number? Well, in that case, of course, you can use activity execution. They can execute any code. But within workflow, you can use this API. It has something called side effects. With time can be very non-deterministic based, on if you use system time, it can change. Well, workflows actually provide workflow current milliseconds, which actually gets the time from the temporal server and manages that within the execution of a single invocation of your applications. And things like that, things like thread sync, async invocation, sleep instead of native. For example, thread.sleep, which is non-deterministic. Temporal provides through its API deterministic methods that you can use to actually invoke things. Now, this depends, of course, on the programming language. These rules are going to be much different, let's say, in Java than they're in the Go SDK. But the idea is kind of the same there. Now, next thing I wanted to show is, now that we've seen all this stuff, okay, let's see. We said Temporal is a microservice orchestration platform. This is one way of dealing with this. Let's say, of course, we have a Temporal server running, and we have our food delivery service application, which includes a workflow that our main business logic and set of activities that we want to use to communicate with third-party services. Now, this is a very good, kind of typical way of us writing microservices. We orchestrate them. We have our application. We communicate with the third-party services, and that's that. Now, adding Temporal to the mix, you have out-of-the-box handling of intermittent failures. For example, if I use, let's say, this activity in the middle to call my dispatch third-party service, and it fails, I can issue retries, automatic retries on my food delivery service application. I can also deal with continuing failure. Let's say my payment service just won't come back, and we set a timeout when we kind of say, okay, this is not going to work. I can start compensate my business logic, and maybe if we have taken some money or the user deposited some money, we can bring that back to them in our business logic and things like that. We also, just by using Temporal, you also have ability for rate limiting. One important thing is we don't want our applications to flood third-party services, number one. And number two, we want to be able to control the cost. We don't want to, for example, hit an Amazon service like 1 billion times and then get a bill back for a lot of money. So, we can configure our workflow and our activities with rate limiting information on how they should and how often they should, what time-based intervals invoke our third-party services. So there is some protection layer on top of that. So that's one way of dealing with this. Now, this is another way, and this is, I think, where really Temporal shines, is if we have our food delivery service, we have our workflow, but our third-party services also use Temporal, and they have these activities. In that case, you still have, for example, in that case, you have the ability on the actual service level to define its own rate limiting information. So you don't have to do it, we don't have in our food delivery service to know how the dispatch service should be rate limited in certain situations. But an important thing is, like, when you have multiple services that communicate and using Temporal, you can have something really cool, which is error handling and propagation. And not only do you have that, but you have it across multiple programming languages. So let's say our food delivery service, we write this thing in Go and use the Temporal Go SDK, and our dispatch service is written in Node.js and uses that SDK. We can deal with a lot of cool stuff across polyglot or programming language implementations. Now, how does this error propagation and chaining work? And I just wanted to show this real quick. Let's say we have 3 services: food delivery service in Go, restaurant service in Node.js, and let's say we have some payment service written in PHP. Now, these can be controlled by different teams of your system and things like that. If you have, polyglot type of environment at your company or whatever you're dealing with. So first of all, we have a workflow in our Go food delivery service that calls an activity. This activity, of course, through the temporal server, as we saw in the task queues and stuff, invokes a workflow in our Node.js restaurant service. That thing, again, invokes an activity, and that activity invokes the activity in our payment service written in PHP. Well, let's say see what happens when actually our payment service raises an exception. Now, this exception, of course, is in PHP code, and it has some information about the actual core exception that happened. With using temporal as kind of a server as an intermediary, or being able to, in this case, we can do things like error propagation, which means that in my activity in my restaurant service in Node.js, I can catch this exception that happened, and I can add more information to it. Then I can actually also catch this exception in my workflow that's executed and add even more information to it. And this can chain back all the way back to my workflow, which is, again, went past the 3 different programming languages. And finally, the error that I get in my food delivery service is not just a 404. It's not just some sort of code. It's actually error messages. For example, I get the payment service core error that actually happened. But throughout this chaining, back chaining, each one of my services added more information. For example, the restaurant service could have added restaurant information, the time the particular order was made whenever this error actually propagated back to it, the customer information. So in my food delivery service, I have full control and information to actually know how to handle this error in a domain-specific way that I really want to. And this is not kind of easy to implement across different or polyglot environment as well. So let's take a look at something else that I'm really interested. I'm into polyglot type of stuff, so my slides are kind of going to be related, or a lot of information about that. I wanted to also talk about something called a type programming approach across polyglot microservices when using temporal. In this case, we have 2 services, service A and service B. One is written in Java. The other one can be written in any of the other SDKs, or the first one as well. And we have, again, a workflow. We have a worker on either side that's connected and talking through a long pole to a temporal server. Now, let's say our workflow sends a command saying, okay, I want to start some activity on a task queue B, and my activity is called my activity. And this activity is actually on my service B end, and that's the green thing in the PHP service over on the right side. So what the server does, okay, says, puts a workflow task on task queue B. This is consumed by the worker of service B, right? It's a completely different language. And the data also, we'll see, is actually marshaled and marshaled. So you can use classes instead of like a lot of workflow languages or DSLs force you to use JSON, force you to use a specific model. No, you can actually use concrete classes on both sides, especially with PHP and Java and things like that. Now, my service B is going to send a command back to the server saying, okay, I've completed my activity. And there's also a lot more information in there that I didn't show, such as correlation information back to the service A invocation. The server puts a workflow task on task queue A, picked up by a worker, and my workflow can continue. Now, this actually, when we write our applications, especially services, microservices in different polyglot environments, we usually do this in an untyped approach. And Temporal also, through its API, allows you to do that. If you look at this piece of code, all you have to kind of think about, okay, it's again Java, sorry. But basically, we say, okay, we want some sort of untyped activity stub, and we provide string-based information. For example, I want some activity named greet. This can be also like, I want some, hard-coded URI to the endpoint of my service that I want to invoke. And also, I have to define In an untyped or a typical approach, well, what do I expect the result to be? Is it a string? Is it an object? Is it JSON? Whatever. And then I have to specify the arguments to that. Now, this is problematic. First of all, it's not typed. Second of all, this can change, and I'm using strings and some sort of determinism to figure out how to actually, hoping that this will actually invoke something. Now, with the type approach, and this works across all of the programming languages. Now, of course, this is Java, but let's say I have a Java application where I want to invoke an activity in Go. All I have to do is, since in both sides I have, notion of activities, I can write my activity in Java. Now, I don't have to provide the implementation because that's, of course, on the end of the third-party service or service written in Go. But all I have to do is write an interface, mark it as an activity interface. The method on this activity that I want to call in the Go implementation has to match as far as greet. And now that I have this interface without an implementation, I can actually use a typed stub. So you see on line 2 of this line, I can actually say activities.greet instead of, if you see on top, I have to actually put greet inside of a string as a parameter to my untyped invocation of my activity written in Go. So that is cross-programming language, and I think this is a great thing kind of from development perspective as well. So that's all I had, as far as the presentation goes. More information, please get in touch. And if there is time for the demo, I really don't even know what time it is or how long I talk for, but we can do a short demo if you want to or not. Just let me know what to do at this point.
I think it'd be good to have a demo. Yeah, I'd like to see it.
All right. So, I mean, any questions so far so you guys don't forget about them, or we want to do this after?
Well, I do have some more questions, but if you have the demo ready, I think it'd be great.
All right, so no problem. So one thing about me, now we talked about all this technical stuff and all that blah, blah. Okay, when I do demos, I like to do fun things. A lot of times when you see me even on the office hours or if I do YouTube videos, I like to not take this seriously. So for this demo, what I wanted to show is basically a game. And this particular game is a snake game, and it has 3 parts. And I will actually, if you guys don't mind, copy this URL and show you how you can run it yourself. So yeah, let's go ahead. So what I'm going to show you today, you can run it yourself. Here are all the instructions on how to do it. So we're going to write a game that, of course, uses the Temporal Server and has 3 services written in PHP, Go, and Java. And each service is going to be responsible for parts of it. The Java is going to be overall responsible for the game controls, as far as starting the game, stopping the game, and things like that. The Go workflow, and you can check out the code and contribute or just tell me it sucks or whatever. It's actually responsible for game information, like how big is the board, blah, blah, blah. And we put all hopes in our PHP workflow, which is actually going to be bombarded with events from the game as we move this little snake around the board, and is responsible for the actual movement of the game and things like that. So to run the, go ahead.
I think you might be showing a different window.
Yeah.
We just see a cursor. We don't see anything but your cursor.
Oh, I'm sorry. Let me try again.
So you can do like just a tab share. And if you open
Is this better now? Or?
Yeah, that's it.
Can you guys see this screen now?
There you go.
Yep.
Sorry about that. I wasn't. Yeah. So, anyways, so I wanted to show this. This is the game. We'll see it here in a second. And here are the instructions on how to actually start the first service, microservice in Java. The second one in Go, and the third one which uses PHP and the Roadrunner server to actually to run the PHP application on there. So let's go ahead. I think, I tested this hours ago. I don't know if demagogues will help me today or not. I have the three services started, which is the Java service, the Go service, and the PHP. And through my ID, I'm going to go ahead and start the game. Actually, before I do that, what I want to do is, this is kind of show the web UI. Now, these are some of the workflows I started before. I think through here, I can select last 10 minutes, which there shouldn't be any. So let's go ahead and I have a little Java application, which is actually starts the game for me. So I'm going to go ahead and start it. And this is the game. It's so cool, right? I can use my keys to move the snake around the board. And, I got to eat the apple for my snake to add another, become larger. Now, all of this is handled by the workflows. And, I have a hard time with this game being the board so small to show it, but I'll try. If we see here, we're actually running some workflows. And I'm sure I was too late. Our snake hit the bottom, so the game is over. Now, when we close the game, as we'll see, our workflows should have completed. Now, one thing I really wanted to show, which is, go ahead.
We lost you again. We're looking at a black screen.
That's weird.
That is weird.
Yeah, because you switched a bunch of times and it was fine.
Am I back?
Yep. I've never seen that happen before.
Yeah. Now, and that's cool. You can write applications like that too. But the reason I wanted to show off this with a game, and let me try. Okay. Here you're back. Whoa! I gotta move the snake. Sorry, I gotta start it again. I am too old for this. I should not be playing games. By the way.
Yeah. Every time you close that, it's gone again. I think when you close that Java window, it takes it away for some reason.
Oh.
The GUI somehow screwing something up.
Yeah, the Java drawing weird.
Kind of a job, right? It's kind of
Definitely Java.
Let's see again. All right, last time. But what I wanted to show basically is when we start the game, and do you guys see my terminal right now?
Mm-hmm.
Yeah, and we actually stopped one of the services they're running. And I don't know, this platform is weird, but let's go ahead and start it. You guys tell me when my screen stops showing. So we're good still? All right, so I'm going to start the game again. And I'm going to keep this window up.
It's gone.
No! What should I do? Oh, I have an idea. Can I try one more time? You guys give me the chance. I actually, instead of then using the client, I'm going to use the command line to start the game. Let's see if that then works. So I'm going to shut down IntelliJ, which is apparently messing with me. And I am going to start the game using the command line, and I have a cool, let's see where we are. I am at the game, and I want to start it this way. Let's see if that works. You guys tell me. If not, I apologize.
That's working.
Oh, well, I'm having some issues this way to start it. This sucks. Let me try again. File, open recent, snake game. Last time. If this doesn't work, I'm sorry, but I'll explain what I wanted to show.
It's blank again.
No! Well, anyways, I'm not having luck today. But regardless, what I wanted to show, and also basically, is you guys saw the snake move around the board. And the idea is that you can stop the PHP client completely, and the snake is going to stop moving, meaning that our first service, which controls the game, can no longer communicate with the PHP service, which is responsible for the movement of the snake. And when we bring that PHP service back up, the snake is going to continue at the same exact location with the same number of the dots that he ate so far. So the state is going to be preserved, and also the location and all the stateful information about the game is preserved across multiple microservices in this, in this case. And I think also, if you guys look at our YouTube channel, you will actually find a video called Temporal Polyglot, and I can also try to link it. And this also has this demo where it actually worked in this case. So anyways, I'm sorry about that. I don't know what's going on with Chrome and doing this. So anyways, any questions or no?
So we had a brief view of the UI, and I saw 3 workflows in there for the first execution of the game. And those workflows are long running, right? Each of those workflows represents one piece of the game logic, like you explained. Is that correct?
Yes.
I thought workflows had to be deterministic. So how does a workflow control, like, are they sitting there in a loop, right? Because that's a loop in your game loop there to, like, take the next instruction and keep going. So are the workflows allowed to loop and do that kind of stuff? Then it doesn't check. Okay.
Yeah, so the PHP service, which is the one that controls the movement, it basically waits for a receive of an event, processes that as far as updates the state of your application, like the XY position of the snake, the number of dots that he ate so far and stuff like that. And then it waits for the next event. Now, the important thing, and that's a very good question, thank you for asking, is where is the timer created? If I tell, for example, my workflow, wait on the next event, or wait for 10 minutes, this timer is actually created on a temporal server side, not locally on my application that actually has the PHP code. So it's important that the timer, what the PHP guy does is wait a second, or either 1 second, or the event arrives. If I don't get an event for a while, then I can say something is going on, or the user left, or whatever. I don't have to consume my resources. But that interaction is done between your workflow and the temporal server in this case, so you don't have to deal with managing the timer, managing the determinism of the timer and stuff like that as well. I hope I answered your question.
Sure. I did a second one, and then I'll let Paul get to some of his. So I couldn't help but notice, and by design, the temporal system is between every service for every communication all the time, or not all the time, but the majority of the time. In really large installations, how large is their temporal footprint? Like, what percentage of stuff is temporal? Now that you send in giant amounts of data, you're potentially sending it twice all the time. Every time 2 services talk to each other, they go through temporal. Do you have problems with that, or what kind of scale does that network is free in the internet?
Yeah, that's a good question. Now, of course, I'm not an expert in that. We got guys and they can answer this much better. But the idea is that, yes, like any other application, as far as the temporal server goes, the bottleneck is going to be the database in the end. So the amount of information that you store, the amount of services you have, the amount of workflows you want to run per second is going to be probably the bottleneck. Most likely is going to be at the end the database that you choose. There is companies that deal with that. They have bigger, some people have teams that deal with databases and scaling of those. So it really depends on the use case. For most of the use cases, as far as even running this locally, you don't have to worry about it. But yeah, you have to worry about scale. And thankfully, like we showed, you can scale up, you can scale down, you can deal with this type of scale, which you will have, your large application, whether you use temporal or not in the end anyway. So.
Cool. Anybody online want to ask some questions before we start?
Yeah, so you've got 3 supported databases, Cassandra, MySQL, and Postgres. My impression is that Cassandra and MySQL are the primary ones used. How common is it for your users to be using Postgres?
From what I've seen in the community, there are people using it at the community site, and you can see, a lot of people say, because we support, of course, not people using the Temporal Cloud, but any community we support with the same way. And you can see there is some. By default, we in our the Temporal cloud offering, we use Cassandra, I believe, so because it's best for scaling in this case, I believe. But I think recently, even for development, we offer Docker Compose files for the community to get started, and also you can take that and use in production as well. We recently switched to Postgres as the default for kind of stability and things like that. And also the footprint. So it depends, really. It depends, I would say.
Any other?
I'll let you go first, Paul.
Go ahead, Casey.
Yeah, well, I have an interesting mandate here at Weave in providing abstracted infrastructure. I'm curious your thoughts on multi-tenancy around Temporal.
Yeah, and I have to tell you, please use the community site. That's one of the few things I really don't know much about, honestly, and I would provide probably a wrong answer. But yeah, go to community Temporal.io and please ask it, and you'll probably get hundreds of responses right away. I'm sorry, I wish I could, but I just don't think I know enough about that yet in order to give you a good answer. Sorry.
So I had a couple questions. You talked about multi-cluster, and then of course it's always about the database. I'm still trying to understand, let's say going across multi-regions, maybe even different cloud providers. Let's say we're in Kubernetes. I mean, is that, what's the kind of data flow in and out, and do I have to cross my databases across these providers? Help me understand what you mean and how you really implement a multi-cluster solution.
From my perspective, from the product side, we do provide clusters in different regions. So if you, I'm sure you can do the same without that and doing the same. But yeah, we have different clusters, and depending on what's the closest to you, you can actually use that particular cluster. I don't know much about it yet, but there is multi-cluster replication that Temporal is capable of, meaning that, if one of your cluster fails, you can replicate it. But the state of that, as far as how exactly to do that, I'm not an expert on that. But I'm sure, again, community website. Please ask those questions and don't be shy either. Go ahead. But yeah, it is possible to do what you're talking about. I don't know, as far as effort goes, I've never been in that situation as a sysadmin to have to put one up, but we have people that in the community or at Temporal, they're doing it all the time. So go ahead and ask that, please.
Another question I had was, I mean, this is a great solution for, large scale. How small can you get, though? I mean, you look at some of these IoT world, experiences, or even like in factory floor where you have low, very small footprints. What's the smallest you can go with Temporal?
That's a good question. I think it goes more about what is the use cases for Temporal, and whether you have large or small applications. If you care about resilience and recovering from errors and things like that, and being able to run long-running applications without many issues, yeah, probably Temporal is a solution for you. Now, let's take a look at what Temporal is not a solution for. And one of the things is, for example, a queue. For example, like a Kafka queue, you don't want to start a workflow for every single event that you have. So those type of systems where you get thousands of events and you start workflows for every single one, those are probably not very, suited for Temporal, where you're going to have database rights and things like that in order to preserve and have this part of resiliency for your applications. And that's fair. There is always use cases. Something is good for it, something not. But you can use, again, if you even have a website where you call third-party services, just a couple of them, and you want to be able that, hey, if something goes down, I can actually retry. I can actually have some sort of recovery from error handling and things like that. And probably you can consider using Temporal, of course, as well.
Any other questions?
It looked like at one point Kafka was part of the dependencies. Do you know what that was backing and what it got replaced with?
I know, yeah, on the server side, we did have a dependency of Kafka, but that was recently removed from what I read. What it was replaced with, I think, I'm not sure, honestly.
It was implemented inside the temporal server itself.
Yeah, okay, there you go. Yeah, that's right.
It's basically communication between the different services that you described for the internal,
Yeah,
part
I know
of the
yours.
server.
Yeah, it was Kafka, but I think now it's implemented.
I guess my real question there was, I think I remember seeing a throughput number that seemed high for the backend databases, so I was curious if there's something else going on there in between.
No, I don't think so. No.
One other question I had, similar to multi-tenant, but not really going that way because I know the answer that you gave. But you did talk about encryption. You did talk about data kind of separation. I'm trying to understand how granular can you put writes on the data that's actually being that's flowing in and out of the systems.
Yeah, you can write your custom data converters. So any sort of data flows into your workflows. For example, when you start your workflow execution, you have your input parameters. You can define data converters for that can encrypt or decrypt on the other side this information. Same thing for activities. Same thing for information of signals and stuff like that come in and out to different services and be accessing your workflow. But also you have each workflow provides also a set of, Temporal provides interceptors. And that way, even, at any sort of stage, like before activity is executed, after activity is executed, before workflow completes, before it starts, after it starts, you have control to intercept all the data and actually be able to do with it, whatever you want at this point. Go ahead.
Admission controller type stuff where you can kind of get in between stuff, I guess, is what you're saying. Sorry, I interrupted you.
It's based on MTLS as well, so I'm assuming where people just do client certs.
Gotcha.
You can throw anything on the internet if you only accept certain client certs that you control.
Yeah. Is there samples of that type of thing in the community, or how to do that? You talked about the adapters to the database. I just wondered what's available out there. Do you know?
Yeah, we do have a data converters example. We do have, I think, for both Go and Java currently. We do have samples for interceptors as well. So there is a lot of information, as samples already. So when you come in, I would, get started with the samples for each, if you're choosing whatever your programming language of choice is to get started. I would first take a look at samples. Or definitely also query the community website. There's a ton of information, and also, hit us up on Slack as well, to see what is there, what's not there, and things like that.
And I have one more.
Go ahead.
Does it make sense? I mean, it doesn't. It sounds like there's nothing preventing you from doing synchronous and asynchronous together and making decisions along the way. I mean, do you find any race condition issues? Do you find some other things that may happen when you do some things like that? Do you prevent those types of situations?
Yeah, I mean, in a lot of these types of situations, you have to, one important thing when writing your business logic with Temporal is making sure, like those little rules we showed on the slide, as far as using the deterministic API provided by Temporal, and to make sure that you use it. A lot of times people run into issues, and we take a look at it, and they, for example, use system clock. There's some non-deterministic code in their execution of the business logic that cannot be replayed, and which they run into issues. But in most cases, that in my opinion, from what I've seen so far, is the case where you run into some. Of course, there can be some edge cases. We do find bugs. It's just open source, right? So yeah, if you find that, then make sure you contributed a solution, or you open an issue like with any other project, and it gets fixed.
Thank you. I'm out of my question quota.
Keep going. I hope I'm helpful here.
Yeah. So like the most common orchestration or workflow task that I run into is CI/CD. Is this something that companies do use when they grow a very complex CI/CD? Is that a common case that you're seeing for Temporal?
I think yes. I mean, Temporal is again, you can write your pipeline, CI/CD. You can write really long-running stateful workflows. In the end, again, you have to look at the resilience part, the fault tolerance, all those things that come with it. As far as the solution, again, you're writing your programming language. You can really express anything that you want, and I think the use cases are really endless. As long as you really look at the core kind of propositions of the Temporal, and that it brings to you. But yeah, I mean, there are people, I think, using CI/CD. There's people writing DSLs on top of Temporal. I'm a big DSL guy from CNCF, so that's one of the things we're looking at. It's a lot of different use cases that we see that people want to use Temporal for, and they're using it currently as well. Check out the use case, the link that I provided to the docs. You'll see all the other companies what they're doing as well. Case studies. Yeah.
Any more?
Do you have any insider information you could share on how close a Python client might be?
All right, I'll answer it this way. We specifically don't want to give any timelines community-based right now. I'm sorry to say this, but that's how it is. Yeah, I mean, I think a lot of stuff is coming up. Of course, Temporal wants to expand into a lot of different languages. Community efforts, and you can find them, and I can link them too. There are some community efforts even in C# and things like that. There's a lot of community, again, like I said, writing different types of DSLs on top of Temporal as well. So there are some low-code, no-code solutions that you can run on top of that if needed, or if that's the use case that you might have at your company. It's a lot of movement going on, but I'm sorry, as far as timelines and deadlines, I'm sorry.
How about this? Can you confirm that work on the Python client is happening right now?
I don't know. You guys have to remove this from the editors out of the video. I'm getting me in trouble here, but yeah. Best thing is, I'll tell you, ask on the community side, put a question, talk, and you'll get some answer for it.
I've actually been eagerly tracking it for literally a year, and a Python client is the major blocker for us.
Jeez. All right. I'll make sure I get back, Riley, which is our head of product. I'll tell him that this is a very important question to answer and get back to you. I promise.
Well, I think it's been a great presentation. As you can tell, you have people here that have been involved with it for a while, advocates, and a lot of us are newbies. So thank you for kind of going the spectrum for us. But thank you so much. And I guess as you put on there the slides, we can contact you in that manner. And anyways, just want to thank you very much. We'll talk to you later.
Thank you, guys. And I hope you guys, it's like 9:45 here. I got kids stuff too. And thank you very much. So if I can drop off and yeah, hit me up anytime. If you want the slides, I'll send them out. Just ping me and you'll have it all. Thank you.
Thank you so much.
Bye.
Bye.
Know what I'm doing. Is that the right button?